Good morning to all. Myself, Dr. Arun from Aerospace Engineering Department. Today, I am going to take one topic from fluid mechanics for aerospace subject. Topic name is major and minor losses in pipe. So in that things, what is meant by major and what is meant by minor losses in pipes. So the losses, it can be classified into two types. One is called as major losses. Another one is minor losses. So in that major losses, it have a like pipe major losses. It will be caused because of the friction resistance along the straight sections only. For minor losses, it can be caused by like disturbance, like pipe bending, fittings, elbows, and reduce the pipe diameter, suddenly enlarge the pipe diameter. These are all the things. It will be under the category of minor losses. So you see that figure. So in that figure, the major and minor losses, it can be uh, shown in that figure. So in that the major losses, it can be caused by the pipe length. If the length is more than 100 meter, the definitely major losses it will happen. Next one is minor losses. So in that minor losses, it will be caused because of the pipe fittings, walls, bends, turbulence, and energy losses. And next one is that minor losses, it can be calculated by using Darcy-Weisbach equations. So in that Darcy-Weisbach equations has been developed by the Darcy. So if the formula is HF equal to F into L by D into V squared by 2G. So here the HF is friction head loss. F means friction number. L, it is a length, and D, it is a diameter, and V, it is a velocity of the flow. G, it is a gravity. So in that parameters are like friction parameter, pipe length, diameter, flow, velocity, and gravity. So in that things, the friction factor, it can be classified based on the flow. For if the flow is laminar flow, here the friction factor, it can be the Reynolds number is less than 2300. So here the what is meant by Reynolds number? Reynolds number, it is a ratio of inertial force by viscous force. So for while the laminar flow, if the friction factor is F equal to 64 by RE. So if it is a turbulent flow, so the friction factor, it will be taken from the Modi chart. And the next one is a Modi chart. So in that Modi chart, it can be drawn with the help of two parameters. One is called as Reynolds number, and another one is it is a pipe friction. Sorry, one is a Reynolds number in X direction. Another one is in Y direction. We are using this friction factor and pipe roughnesses. By using this Moody chart, it is a graph in a non-dimensional form that relates the Darcy-Weisbach friction factor like FD, Reynolds number, RD. Another one is a surface roughness for the circular pipe. Next one is the minor losses for the loss coefficient. So in that minor losses, it can be denoted by the capital A. So then that minor losses happen by the fittings, walls, and elbows. So in that head loss, generally we are using this formula like HM equal to K into V squared by 2G. Next one is typical loss coefficient values. For example, if I using the sharp edges, here the loss coefficient is 0.5. If I use a rounded entrance, we can use 0.05. So if the bend is 90 degree, we can use 0.9. If the bend is 45°, we can use 0.4. And the next one is the hydraulic gradient line and energy gradient line. So in that hydraulic gradient line, so it is represent the sum of the pressure head and elevated head. So if the formula is P by rho g plus Z, so here P is pressure and rho is density of the fluid, G is gravitational force, H it is a height of the or length of the pipe. Next one is the energy gradient line. So in that energy gradient line, it will be using this following formula, like P by rho g plus of V squared by G plus Z. So here the P is pressure, rho is density of the fluid, G it is a gravitational fluid, and V it is a velocity of the fluid. By using this energy gradient line and hydraulic gradient line, we will measure the energy loss during the pipe during the flow through the pipe. So last one is application and summary. So in that applications, while designing efficiency, we can calculate the pipe size and fittings, and by using this hydraulic gradient line and energy gradient line, we will analyze the energy distribution and losses. So thank you.